All right, good evening, everyone. Welcome to the Leitner Observatory Tuesday night public live stream on YouTube. Beautiful night up here at the Leitner Observatory in New Haven, Connecticut. Let me turn on my camera here. Hi, I'm Michael Faison. I'm the director of the Leitner Observatory and Planetarium. I teach astronomy here at Yale. And I've been doing these live streams on Tuesday nights in lieu of our usual public observing and public planetarium shows. And coming on YouTube to talk about what's up in the sky, any interesting astronomy news, to show live views through our telescopes when it's clear. We have a nice clear night tonight. In fact, it's really pleasant. It's like 70 degrees outside, perfectly clear, not too humid. So really nice for observing tonight. I have a couple of students that are going to be using the 16-inch telescope shortly, so you may see the dome over here on the right side of the image rotate around as my students are connecting to the telescope and setting up for their observing. I'm looking at the observing deck with a little security camera that's out on the deck, showing me where the 12-inch telescope is pointed on its mount. And we're pointed at Jupiter right now, so I'll show you that live view in just a second. I'm not outside on the deck. The last couple of streams I've been outside on the deck, and it's not that it's too cold tonight, but I wanted to do a couple of things inside the building tonight. I'm inside my staff office where I have my little recording studio for teaching my online classes, because everything's online these days. But I am here live, and I do have the telescope set up live. If you're in New Haven, you could come stand in Farnham Gardens in front of the telescope and wave at us, and we'd probably see you in the camera there. Pay no attention to the astronomers behind the dome. Is there anyone out there? Is there anyone in the park? Sometimes you do see people walk up to the telescope and look over. I haven't seen anyone trying to break in or anything like that, thank goodness. The building's locked up and it's got alarms and cameras and everything, so we're pretty safe from being invaded. I suppose someone could come and jump on the telescope while I'm observing, but I would see that. Call the police or whatever it needs to be done. Students log in remotely, actually, over the internet. So I am teaching, even though our classes are all online, remote, very few in-person classes here at Yale right now. Since we do have robotic telescope mounts on the 12-inch and the 16-inch telescope. And there are a couple of other telescopes I can set up for remote observing. My students are logging in and doing their observing labs like we usually do in the fall. So it's pretty amazing, actually. We have the telescope, the technology to do that now with robotic remote telescopes. So good evening, everyone. I'm watching the live chat from time to time, so if anyone has a question about what I'm doing tonight, what I'm pointing the telescope at, or anything about astronomy or Leitner Observatory or astronomy news or astrology, if you like. I had a student the other day ask me to cast her natal horoscope, and I said, I'd love to do it. So I'm going to actually use my planetarium program to do her horoscope and maybe make a video about it, because it's kind of fun to figure out where the planets were on a particular date and make a chart showing where the planets are. Of course, it has no predictive power whatsoever, but it's still a lot of fun to check out. I should start a business. Yes, absolutely. Yale astronomers making horoscopes, or not a horoscope, a natal chart showing the positions of the planets. Well, let me show you what I'm looking at right now, since we have a really nice sky tonight. Right now I have the telescope on Jupiter, and I thought I would move over to Saturn. And then if it gets high enough in the sky, I want to move over to Mars. So you may have heard in the news, Mars is close to the Earth today. I think closest approach was at about noon or maybe 10 a.m. I think it was 10 a.m. We'll look at the calendar in a minute. So I was looking at Mars last night around midnight. Mars is going to be highest in the sky around midnight, or actually 1 a.m. daylight saving time. So we were looking at Mars last night around midnight. It was mostly cloudy, so the viewing wasn't that great. Maybe we'll try that again tonight, take some videos and post them. And if we don't get to see a live view of Mars, I can at least show you the pictures that I took last night. My concern about looking at Mars right now is that it's probably behind the East Dome. It's probably behind the dome where the 8-inch refracting telescope is. And we have some trees over to the east, so we'll keep an eye on it. It was definitely up, I could see it from the 12-inch telescope last night around 9 o'clock, and it might be visible a little bit earlier than that. So we'll give it a try. I have another camera set up on the observing deck right now, which you can see in the live camera image here. There's a tripod that's behind the mount of the 12-inch telescope there. It's actually completely dark out on the deck right now. And so the reason that you can see the piers and the deck and the telescope is because the security camera has infrared, near-infrared lights on it. If you've ever seen one of these cameras, they have a ring of sort of dull red lights around the camera. When it gets dark, they cast that infrared light out, and the camera is somewhat sensitive to near-infrared light. So not really quite night vision, but it does let you see when it's completely dark. And so this camera that's behind the mount, I put it behind the mount to shield it from the light from the infrared lights from the security camera on the deck. And that is an all-sky camera. So it's a fisheye lens looking at the entire sky. So let me show you what that looks like. I took an image a little while ago, and this is proof that it really is clear outside. So this is a 30-second exposure from that all-sky camera, which is connected to a computer out on the observing deck, the same computer that's controlling the 12-inch telescope and taking pictures of Jupiter for me right now. And so you see a lot of light pollution. Here is the 16-inch dome, the 16-inch telescope dome, the west dome over here. And you can see the windscreen is open and the shutter is open because we're going to be using the telescope shortly. And then you can see the 8-inch dome, the dome with the 8-inch refracting telescope inside it over here. And then I hope you can see this on the stream. You can see some of the bright stars that are out, and stars that are really too faint to see with the naked eye given the light pollution that we have. And I can actually adjust the contrast and brightness in this image a little bit to improve it. This is a camera that we just got a little while ago, a couple of months ago, to assist in remote observing so that we can see if the sky is clear or not here at the observatory. So we've got a weather station now, we've got an all-sky camera, and eventually when I have time to do this, it's going to go up on the roof of the building and turn on automatically at night and show us what's up in the sky if someone's observing remotely. And what I'm actually interested in doing is doing time-lapse movies, right? Taking a picture every 5 minutes or so and then making a movie of things, of the sky turning and satellites going by and airplanes going by. I don't really care about the airplanes, I'll get the airplanes, but satellites and meteors, I'm actually very interested in taking a census of fireballs, really bright meteors that can happen at any time. And NASA actually has a network of all-sky cameras around the world that are looking for fireballs all the time. And so if you get telemetry, if you get a line of sight to a fireball from lots of different locations, you can triangulate where it was in the atmosphere, and that's actually interesting scientific information. Hello, Westport. Yes, hello from New Haven. This is from a few minutes ago, or right before I started the stream. Let me take another picture and see if it's getting cloudy or not. I hope not. Okay, I'm going to take a 30-second exposure here, and actually I think what I'll do after I take this exposure is set it to automatically take exposures for the rest of the night. So we'll see how that works out. So I'm going to say take photo. That'll start taking images. And while that's going, I can point out some of the bright stars and constellations that are up. We'll look at the Planetarium simulator here in a minute to talk about what's up in the sky. But I've talked about some of these bright stars that you can see even in the light pollution of New Haven, like the Summer Triangle, right? There's Vega, the bright blue star Vega, the bright yellow star Deneb, which is in Cygnus, and then down here you can see Altair. This camera, because it has a fisheye lens, there's some distortion. Okay, here's the new image. So the sky has turned just a tiny bit in the minutes that passed since I took the first image. I think it's in okay focus, although maybe I'll play around with the focus tonight a little bit and see if I can get it a little bit sharper. As with all fisheye lenses or all wide-angle lenses, the stars are sharpest kind of in the middle of the camera, the middle of the field of view. And then as you look to the edge, there's some distortion. We have the same distortion with the fisheye lens that's on our Planetarium projector. So if we ever have live Planetarium shows again, you can see that the stars right in the middle of the dome are really sharp. And you don't notice the distortion on the stars at the edge, but if you get really close to them on the dome, you can see they're a little bit stretched out. There's a little bit of a color cast to them. Anyway, so there's the summer triangle, and it turns out that the Milky Way goes right through the summer triangle, right along the axis of Cygnus the Swan. And I think, I mean, I may be fooling myself, but I think I can see more stars kind of in that plane. I think I can kind of see a star cluster over here. It's a little bit of a diminishment of quality here that you're seeing on the stream because, number one, I'm doing a remote access to the control computer, which is out on the deck connected to the telescope. So I'm doing a remote control of that computer, a remote login to that computer, and then I'm sending it out on YouTube, which is also compressed. So there's going to be some compression artifacts, and some of the fainter objects won't be visible. I can also see over here, well, I can see Cassiopeia right there, right? There's the zigzag of Cassiopeia, also in the plane of the Milky Way, like so. And then over here, I can see the square of Pegasus right there. So there's the 4 bright stars that are in the constellation of Pegasus, and the bright star Enef, which makes up the nose of Pegasus, the flying horse. So we're getting late enough in the fall that we can start to see the whole Perseus and Andromeda Greek myth constellations coming up in the northeast at sunset. I'm a big fan of all these constellations. They've got some of my favorite deep sky objects, and I love the fact that there's this whole part of the sky that's dedicated to the Greek myth of Perseus and Andromeda, with Cassiopeia over here and Cepheus the king over here. Let's see, actually, where is the, we should be able to see the North Star, and the Big Dipper is probably too low, but this is the North Star right here, and there's the Little Dipper right there. So normally you can't see the stars in the Little Dipper with the light pollution, but in a 30-second exposure all-sky camera, you can see it, and it actually helps you really tell just how clear the sky is tonight. And as I was saying before, I could play around with the brightness and contrast here and make it look a little bit, make the sky look a little bit darker. Let's see. Yeah, there's some tricks I could do to bring out to subtract off the light pollution and make the stars stand out a little bit better. So I'll be working on learning those tricks as I learn how to use this camera. Something that you can see over here, and I think I can see it in the image, but again, I might be tricking myself. If you look at the square of Pegasus right here, the constellation of Andromeda is coming off of this star to the northeast. So I don't know if you can see this V-shaped pattern of stars. So 1, 2, 3, 4 stars, and then there's another fainter line of stars right next to it. So 1, 2, 3, 4 stars. And if you count 1, 2, 3 stars of the brighter stars over, and then 1, 2, 3 of the fainter stars up, there's a little fuzzy patch right there, and that's the Andromeda galaxy. So the closest big galaxy to us, 2.5 million light years away. When the sky's really dark, you can see it with your naked eye. You can easily see it with binoculars, even if you got some light pollution. I was looking at it last night with my binoculars. It's pretty neat that you can see that light from a galaxy 2.5 million light years away. Let's see if there's anything else I want to point out in this image. I think I will just go ahead and start my time lapse. So hopefully this won't interfere with other things I'm doing with the computer. So I'm going to say take autosave an image once per 5 minutes maybe. All right, every 5 minutes. And number of exposures, I would say continuous, I guess. Do I still have to tell it how many exposures I want? Why don't we go with like, first time I've done this, let's take, I don't know, 50 or so exposures. So that would be 50 times 5, 250 minutes. Yeah, it's probably about how late I'm going to stay tonight. And I will say take photos, and that's going to start taking photos every 5 minutes, and we'll see how they turn out. Let me show you what the telescope's looking at. So if I open up the telescope control software here, you can see I'm pointed over there at Jupiter. And so let's look at the camera software. See, yes, we're still on Jupiter. And I have to say, it looks pretty good tonight. Last week, or no, I wasn't on last week because we had the presidential debate. Boy, I wish I'd skipped the debate and done public night. Anyway, 2 weeks ago when we were looking at Jupiter out on the deck, it looked not great because we had a really turbulent atmosphere. We had very poor precision, angular precision, or seeing is what astronomers call it. What's the finest detail you can see through a telescope? And tonight it looks really great. I don't think I've seen as sharp an image of the disk of Jupiter this whole summer. So I don't know what it is about the weather tonight, if it's the humidity that's dropped, or just the winds are very steady, or if I'm just looking over a different patch of atmosphere. I'm not looking over the city of New Haven anymore. I'm looking sort of more to the southwest. It looks really great. And so I've been every so often grabbing a video of Jupiter, and later on I'll go in and make a sharper image. I can really see the equatorial band, so let me zoom in a little bit so you can see a little better. Now zooming in, it doesn't really give me more magnification because the pixels are a fixed size. It just changes how it's seen on the screen. It's the size of the pixels in the camera and the focal length of the telescope that really determines how much magnification I get in the image. And it's really the atmosphere that determines how much detail I can see. So if you have an unsteady atmosphere and you try to magnify it a lot with a long focal length telescope or a short focal length eyepiece, you're not going to see any more detail. You just blow up the blob. It's like, you know, when they make fun of those police procedurals where they say enhance, and somehow they can magically zoom in on a blurry image and it gets sharper. If only we could do that in astronomy. So it's the steadiness of the atmosphere that determines how sharp the image is, and the focal length of the telescope that determines how big it appears when you take a picture of it. This looks great. And something else I can do, I can look at kind of in the vicinity of Jupiter, are the Galilean moons. So the Galilean moons are much fainter than Jupiter. So if I take a longer exposure here, then Jupiter will be overexposed, but you'll start to see little dots of light pop out, right? So you can start to see them there. And they're in the equatorial plane of Jupiter. So they're orbiting around in the same plane that Jupiter is rotating. I mean, the equatorial rotation plane that's defined by Jupiter's rotation. And so these moons formed like little mini planets around Jupiter, which was its little mini star. In some ways, Jupiter is like a star in that it's mostly gas, but it's much less massive than a star, right? So Jupiter is actually about 1/1000th the mass of our sun, and that's about a factor of 100 too low for it to turn into a star. So, but gas giants we know are very common in solar systems. So this looks great. This looks just fantastic to me. And again, I'm going to just take a quick picture. And I'm going to go look at my simulator, my sky simulator, to see which moons are which. So I'm going to switch over to Stellarium here. And this is my Planetarium simulation program that I've demoed in quite a few live streams. And I will first just look at Jupiter here and zoom in on Jupiter and see which moons are which and sort of confirm what it looks like. Yeah, I don't see the red spots. If we were to wait a little later in the evening, maybe Jupiter would rotate around. Yeah, it looks like you'd have to wait quite a while, maybe 11 o'clock or so before the red spot rotates around. But if we go back to now, the order of the moons is Io, Europa, Ganymede, Callisto. And that's actually the order that they orbit from Jupiter. So Io is the closest in it's on the smallest orbit around Jupiter. Europa is the next, Ganymede, and then Callisto is the next. And Ganymede is the biggest of these moons. So if we go back to the live image from the telescope here, so Io, Europa, Ganymede, Callisto, those are the moons that we're looking at tonight. And it just looks beautiful. I think Jupiter's looking fantastic. Because it's so sharp, it would be neat if there were a moon shadow or if the red spot were there. But I think it looks quite good for the view from our little city observatory. Of course, if you were on a distant mountaintop, if you were at Lowell Observatory right now, or if you were at Mount Wilson Observatory right now, as long as it's clear there, the air would be much more steady. Let's move over and take a look at Saturn, which is still close to Jupiter in the sky. So just going to zoom the camera out to show the whole field of view. And I'm going to switch over to the telescope control here. And there's Saturn right there. All right, and now I need to command the telescope to move. Let me just make sure I have the right object. Yep, Saturn's there. And I'll click on slew, which is astronomer talk for move the telescope over to those other coordinates. So slew, and then if I'm quick enough, I can bring up the camera, the deck camera, and you can see the telescope moving a little bit to the east to point at Saturn, just a really small move over. And so let's go back to the camera view now. Okay, and there's Saturn right there, just where it's supposed to be. And let's adjust because Jupiter was so sharp, I have high hopes for seeing some detail on Saturn. So let's zoom in on Saturn here. Yeah, Saturn's looking pretty good. I've seen better, but this is pretty good. This is above average, I would say. And let's adjust the exposure time here. You can see the gap in the rings clearly, which we couldn't see 2 weeks ago. Can clearly see the light equatorial band. You can see the Cassini division. So that's called the Cassini division between the brighter A ring that's closer to the planet and the fainter B ring, which is a little bit further out. And the reason that there's a gap there is because of the gravitational interaction between the particles in the rings and the moons of Saturn. And it's Enceladus, it's the moon Enceladus that actually creates that gap. So if there were a little particle orbiting in the gap, the moon Enceladus would be in a resonant orbit and it would pull it out. So you don't see particles in the Cassini division. Getting a little bit of color weirdness because of the way it's trying to adjust the color, the white balance. But it looks great. And I can clearly see the shadow of the planet on the rings. Because we're seeing Saturn to the south when the sun sets in the west, that means that Saturn's at about 90 degrees to the sun. And so the sunlight's coming from the right, the west, the right side of the sky, and it's casting a shadow back. It's dancing around a little bit, but it's not as bad as it has been. And I'm again going to try and grab a little movie here. The rings, of course, are not solid. The rings are made up of hundreds of millions of particles that are the size of grains of sand up to boulder size. And they're covered in ice. And they're constantly colliding with each other and shifting around in the orbit. And there are moons that are orbiting close to the rings that keep the rings confined into a particular orbit. But people who study planetary dynamics of how things orbit other things suggest that the rings are not stable and eventually they're going to dissipate. So it's going to take millions of years, tens of millions of years, I forget the order of magnitude, but more than millions of years, and the rings are going to be gone. Let's look at the moons of Saturn too. We saw the moons of Jupiter. Let's look at the moons of Saturn. So they're much fainter than the planet. So again, we have to overexpose the planet. And there come the moons. I'm going to bring down the saturation here because I'm getting some weird color from the... it's trying to set a white balance, which is why I'm getting some weird color. Great, I see there's a really faint moon there, another one there, another one there, another one there, and there's the moon Titan over there, which we've actually landed a robot on. So in 2004, we landed the Cassini probe, the Huygens probe, which was attached to the Cassini orbiter on the surface of Titan. So we do have images from the atmosphere and surface of Titan, and it is a very interesting, place. Let's see which moons are which. So let's switch back over to the sky simulator and leave Jupiter behind and zoom in here on Saturn. Okay, so it looks like we've got Enceladus, Dione, and then Titan is that bright one over to the left. The brightest one is always Titan because it's so much bigger than the other moons. Dione, Enceladus. It'd be interesting to see if we can see Mimas. Mimas is the Death Star moon. And if you don't know what I mean, Google an image of Mimas and you'll see what I mean. And then Tethys and Rhea then are the other ones. So let's switch back to the live image and see what's going on there. Let's see. Okay, so we've got, I don't know if I could see Mimas there. I could try again to take a longer exposure here and see if I can pull it out. But we have Enceladus right there. We have Dione. We have Titan over there. And then Tethys and Rhea. Rhea is one of the bigger moons, so you can often see that. If we zoom out a little bit, I wonder if we can see Iapetus, our Hyperion. One of those could be Iapetus. Let's see. Again, mess with the color balance here. A little bit too blue. But I'm really just affecting the way you're seeing it on the screen, so you could change that later. There's something down there which I think could be a moon. Let's go back and see if there's anything out there. That looks like that's a star. Yeah, so that's just a star in the background. There's Iapetus way over to the left, to the east of Saturn, and there's Hyperion way over to the west. So they might be out of the field of view of the camera. Oh, there's one over there. Oh, nope, there it is right there. There's Iapetus over there. Also a really interesting moon. It has this white spot on it, which was actually a big plot point in the book, the 2001 A Space Odyssey book, the Arthur C. Clarke book, the fact that Iapetus had this white spot on it. And then there is Hyperion over there, and that's a star, and that's a star. So yeah, we got a lot of moons here, and I don't think I can see Mimas. Try to... Yeah, I'll have to look at some... do some image processing to potentially bring out Mimas. Try taking a little movie there again. Okay. All right. I'm going to go back to the auto white balance. Yeah. Okay. And one more time, we'll show the rings before we go on. Looking really great tonight. Now, as I've said before, nothing really compares to getting to see Saturn and its rings with your own eyeballs, looking through the eyepiece of a telescope live. But this is the best we can do for now for both my students in my classes and those of you who are coming for public night. Okay, let's see where Mars is. So it's above the horizon there. I wonder if it's going to show up in the... I wonder if it's going to show up yet in the all-sky image. It should be sort of over here based on where it is there. What we can do is point the telescope over in that direction and keep checking back and see when it clears the trees, and then try to get a live view of Mars. And I'll show you the image that I took. I took a couple of images. I'll show you two of the images that I took last night at midnight. Of course, when when it's later in the evening, Mars is higher in the sky, so then you're looking through less atmosphere. So you get a sharper view. It looks brighter and it looks sharper when the object is higher in the sky. All right, let's move the telescope over there. I go to Mars. Now the telescope has a long way to go to get there. So if we were to watch it in the camera, the telescope is actually going to swing around and point towards us, point towards the security camera, and then flip over to the other side of the mount, and then come down and point at Mars. So that's the design. That's just the design of this robotic telescope mount. Okay, well, while the telescope's going over there, I will talk a little bit about what's up in the sky besides the summer triangle, and I'll talk a little bit about astronomy news. And then I'll show you my Mars pictures, and then we'll try and look at some live Mars images. And if we still can't get Mars, we'll look at something else. And then I'm going to have to go do something else at about 9 o'clock. So I'll be signing off at about 9 o'clock. So let's switch to the sky calendar. So it's October. There's a new evening sky map at Sky Calendar or skymaps.com. So this is a resource that I recommend for people who are interested in learning the sky, beginning astronomers, beginning telescope users, beginner astrophotographers. It's great to learn the constellation positions, especially the seasonal constellations. And the nice thing about the monthly sky chart is that it also shows you the locations of the planets and gives you the dates of when things are happening. So if we look at the sky calendar here, over here on the left, we had Mercury greatest elongation, so it might have been visible at sunset, but I don't think that was a favorable elongation. A couple of close passes between the Moon and Pleiades. Mars nearest to Earth at 14 hours UT, so UT is 4 hours ahead of Eastern Daylight Time, so that would have been today at 10 a.m. So either last night or tonight would be the best time to look. But it's not as if you can only look at Mars one night. I mean, it's true, it's literally closest at that instant, at that hour, at 10 a.m. today. But as you pass someone on the highway, which is what we're doing, right? Mars is on the outside lane and we're on the inside lane. And as we go by, it's true that there's one particular second when you're literally closest. But you're still pretty close to that runner or car or whatever it is on the outside track, the second after, the second before. So I think actually Mars is going to be great for viewing this whole month, and into sort of halfway through November. It's going to be nice and bright and visible. Something that's interesting about this particular opposition of Mars, when Mars is close to us, when we're passing it in the orbit, is that Mars is also somewhat close to perihelion. The exact date when Mars is, or the exact position when Mars would be at perihelion opposite the Earth, is when the Earth is in late, when we are seeing Mars in late August. So we're in early October now, so we're a month or so past Mars perihelion, when Mars is closest to the Sun and therefore potentially closest to Earth. But it's still pretty good, and I think this is one of the better oppositions. Closest in 15 years, I think I saw somewhere, which sounds about right. Anyway, then we have Moon near Aldebaran. So let's see, where's Aldebaran? Aldebaran is in Taurus, so you'd have to stay up a little bit later to see that. New moon on the 16th, that's good to know. Orionid meteor showers. So this is a meteor shower that's not that strong and not that bright, but it's interesting because it's associated with Halley's Comet. So you can see little bits of Halley's Comet fall to the Earth, burn up in the atmosphere, debris from the last time Halley's Comet flew through in 1986. So not a very strong shower, but yeah, they fast, so fast and faint meteors. And new moon is on the 16th, so the moon should be good. You know, you want the sky to be really dark when you have a meteor shower. So that's definitely worth putting on your calendar. I don't see really anything else coming up. So you could see these same stars in my all-sky image from my all-sky camera that I have set up out there, like the summer triangle, right? Vega, Deneb, and Altair, and the zigzag of Cassiopeia. The Little Dipper is pretty faint. It's hard to see when you have light pollution, but you can almost always see Polaris, the North Star, and you can almost always see what are called the guard stars. So these two stars that are closer, that are between Polaris and the Big Dipper, those are the three brightest stars in the Little Dipper. So you can usually see those three stars. And then coming up over here in the southeast are the constellation Perseus, the Pleiades star cluster. Beautiful little star cluster, one of the closest ones to us, so it's bright and big in the sky. Looks great through binoculars. And then what are we losing? Well, we're losing the summer constellations like Sagittarius, the Teapot, and Ophiuchus, the snake charmer, and the bright red star Arcturus. So it's going to be pretty low in the west. I haven't seen it in the sky the last couple of weeks when it's been clear. So we're going to lose those until next year, until next spring, basically, unless you get up early in the morning over the winter and early spring. There's a bright star over here in the southeast, which is basically the only bright star in that part of the sky. So it's the bright star Fomalhaut, which is in the constellation of Pisces Austrinus, the southern fish. And it's fun to find that star and have yourself oriented on that part of the sky. So I look for that in the early to mid-fall, and then you lose it kind of in the midwinter when Orion is rising at sunset. If you have binoculars or a telescope, the other great thing about the sky map, the monthly sky map and sky calendar, is they point out some things that you can see with the naked eye, with binoculars, and with a small telescope. So you can see the description of the object here, and then on the map you can find them where they are in the sky. Like there's this nice globular cluster near the star Enif, what I think of as the nose of Pegasus, the flying horse. And it's right there. You can easily, you can find it with binoculars. It's not easy, but you can definitely find it with binoculars. And then another object that I like to look at with binoculars or a small telescope is the double cluster. So if you look at the zigzag of Cassiopeia and use these two stars as pointer stars and kind of go about 3 lengths, 2.5 lengths, you find these two star clusters that are right next to each other. I'll demo these. I mean, we could point the telescope at them, it's clear. Maybe we should try that, point at the double cluster or the M15 cluster. But I'll show you what they look like in the Planetarium simulator here. Let's see, so let's reset to now, and we'll zoom out, and we'll see what constellations are up in the simulator, right? So here's the sky right now. There's Mars over there. There's the square of Pegasus right there. I pointed out the Andromeda galaxy in the all-sky image, at least I think where it was in the all-sky image. So you find the square of Pegasus. There it is, right there. It's bright. The square of Pegasus is bright enough to see under our light pollution. And you count for the bright stars 1, 2, 3 stars over, and then 1, 2, 3 faint stars up. You can see those in your binoculars easily, and you'll see a little smudge of light, which is the Andromeda galaxy. So there it is. There it is right there. Now, that's not what it looks like to your eye when you look at it through binoculars. You mostly see just the central part, the really bright center part of the galaxy where most stars are. So this is a long exposure, a photograph, right, with a telescope. Those two star clusters I mentioned a minute ago. So M15 is over here near Enif. There's Enif right there. And if we zoom in on it a little bit, you can see there it is right there. So it's one of these, Oops, jumping back to Saturn. It's one of these globular star clusters. Let's zoom in on it again. There we go. Yeah, so really pretty. It's very colorful if you take a picture of it. So the globular star cluster is quite different from, the type of cluster is quite different from the double cluster. We go find the double cluster. Let's see if I can find it using the trick I just described. So if you take these two stars in Cassiopeia, there's the zigzag of Cassiopeia, and you kind of follow them about 2.5 lengths. There's a satellite going by. What is that? Can I catch it? Cosmos 1953, artificial satellite. Anyway, so if you take these two stars right here and use them to point towards Perseus and go about 2.5 lengths and then zoom in, there's the double cluster right there. Right, so this is an open star cluster, so closer, smaller, younger, brighter typically. But you can, and it's fairly big in the sky, so it matches your view through binoculars well. Or if you have a small telescope, it matches a view through your telescope well. I like looking at these double star clusters, or these open star clusters, even when there's light pollution, because the stars, these bright stars, really do cut through the city lights. If you have a big enough telescope, if you have a telescope that's say 4 inches or bigger, you're going to easily see these globular or open star clusters. The simulator is showing us some of these faint emission nebulae over here, like the Heart Nebula. The Heart Nebula, I guess, because it's shaped like a heart. And then this one right next to it is called the Soul Nebula. So you got the Heart Nebula there, and the Soul Nebula there. I guess it's shaped like a soul. This is a little bit deceptive having them in the simulator like this, because you can't really see them at all with your eye to an eyepiece. The brightness of the nebula compared to the sky brightness is just too low. So people who get into astrophotography, these are targets that they like to look at. You put a digital SLR camera on a small telescope, or even just use a camera lens and point it at that part of the sky and take a long exposure, and you can get images like this. We should do another astrophotography class at Leitner Observatory once we open to the public again. I'd like to do that. Okay, let's see what we're doing. Let's see if the telescope's pointed at Mars, and so there's the telescope pointed way over to the east, and the camera disconnects every so often. That's why it's going white like that. So there's it pointing way over to the east, and let's see if we can see anything in the camera now. All right, that's where we're pointed. I think it's still probably too low. What time is it? It's about 8:40. All right, let's look at the camera. Oh, hey, we got it. I was surprised. Now it's pretty low. It's pretty low, but there's Mars. Now let's adjust the brightness and contrast again. Yeah, so it's dim and shimmery because it's low in the sky. And in fact, I wouldn't be surprised if the reason that it's dimming a little bit is because it's still in the trees. So as the Earth turns, Mars is kind of going through in between the leaves of the trees. And so it might get brighter and fainter. Now that doesn't look terrible. Let's make it a little bit brighter. I can definitely see some surface features. And let me adjust the color saturation again so we can see some color there, see what color it is. It's got kind of a yellowish, orangish hue to it. It's not red, it's not truly red, but it definitely has an orangish cast to it. Hey, it's not looking bad. I can definitely see some surface features. I don't think I can see the polar ice cap, which would be, I think it would be over here. As it gets higher in the sky and as it comes out from behind the tree, it's going to look sharper and more steady. Let's see what those surface features should be. Let's look at it in the simulator here. So there's Mars, and let's zoom in on it. And now when I'm pointed on this side of the sky, the image is actually inverted, but it's okay. You won't notice that. So this is Hellas Planitia right here, and this is the south polar ice cap, and then this dark area sort of going right through the middle of Mars. I'm not quite sure what the name of this is. There's Olympus Mons over there, one of the big volcanoes on Mars. Now you're never going to see an image this sharp from really any ground-based telescope. The atmospheric scintillation, the turbulence is just too strong. You can get images like this from the Hubble Space Telescope, which is about a factor of 10 sharper in terms of viewing of Mars. But if you're interested in what parts of Mars you're looking at, oh, and there are the moons of Mars. These are too faint for our telescope. I mean, maybe if we took a long exposure, we could see them. But Phobos and Deimos are just tiny. They're captured asteroids, basically. I forget exactly their physical size, but really, really small. And so you can only really see them with really big telescopes. Let's go back to the live view and see if this simulated view of Mars matches what we're seeing in reality. It's a blurry mess, and we're getting a lot of atmospheric dispersion here. Do you see how Mars looks kind of bluish on the left side and kind of reddish on the right side? So the atmosphere is acting like a prism and spreading the light out. It's turning Mars into a little rainbow. And you don't really notice this, unless you're looking at something really low at high magnification. So that's not terrible, but it's going to look better in about 2 hours or so. So if you have a telescope, or even binoculars, you'll see some detail on Mars. I encourage you to go out and take a look at Mars a little bit later. Around midnight or 1 a.m. would be the best time, but even at 10 or 11 p.m. tonight, it's going to look a lot sharper. In fact, I'll show you. Is it possible to zoom in on Olympus Mons? Someone's asking. Sure. Enhance. It's going to be right about there based on what I see in the simulator. And yeah, I'm not seeing it because there's just too much turbulence in the atmosphere. It's just too much atmospheric scintillation. I mean, Mars is quite small. Mars right now, its angular size is about half what Jupiter's is. So, we saw Jupiter in the camera before. Mars, at closest approach, is about half of that size. Now, Jupiter's a lot further away, but it's much bigger, right? Jupiter is 11 times the diameter of the Earth, and the Earth is about twice the size of Mars. Or Mars is about 3/5 the diameter of the Earth. So Mars is a tiny little planet, a tiny little terrestrial planet. So you get the best view by far when it's at opposition. But even then, it's pretty tiny. When Mars is on the far side of the solar system, it gets a factor of 8 times smaller. So imagine seeing Mars 8 times smaller. It's just going to look like a star. And this is the best time when it's closest to us to look at it. I'm pretty sure those are branches and not clouds that are making it dim out like that. So let's go look at the Mars map and look at the pictures I took last night. And then I think we'll come back and see what Mars is doing. And then I'm going to need to sign off for the evening. So I could also look at my all-sky image and see how it's going. Oh, there's Mars. Yeah, OK. So my theory is convinced. Oh, I'm blocking the view. Let me let me move the image over a little bit, and I'll try to get out of the way. OK, so here's the square of Pegasus in the sky right now. And there is Andromeda, and there's Cassiopeia, and there's Mars right there. So this is from the view of the all-sky camera, which is a little bit lower and a little bit in front of the 12-inch camera, the 12-inch telescope. So Mars might be a little bit higher and easier to see from the 12-inch telescope right now. But once it clears that big tree, it'll be we'll have a much better view. Let me show you the image that I took last night around midnight. So I'll switch back to my browser here. This is Google Mars. So if you go to mars.google.com, you can see a Google Maps style view of Mars, which is fantastic. And that area that was light in the image is Hellas Planitia, which is an area of lower elevation in the southern hemisphere of Mars. If you look at it here in visible light, this is what Mars looks like in visible light. So you see that dark stripe, which is coming from deposits from either volcanism or more likely impacts. There were impacts of dark material on Mars that created these stripes. And then the weather on Mars, the winds, the dust storms, and so forth kind of shifts it around. But anyway, if you look at the elevation map, which shows you really well where the craters are, where the riverbeds, the dried up riverbeds are, the river deltas, and Valles Marineris over here, the Mariner Valley, and then the big volcanoes. Mars is the surface of Mars is really weird. It's got these giant volcanoes on one side, and that's bigger than any volcano in the solar system. It's got this huge canyon on this side, which is as wide as the continental US and 4 times deeper than the Grand Canyon. So huge. And then it's got these sort of other anomalies, like the North Pole of Mars is really low compared to the rest of Mars. And then if you look at the South Pole, it's really cratered. It's really heavily cratered. Yeah, and then there's all these other weird things like volcanoes and craters on top of craters. Anyway, the side of Mars that we were seeing was basically this part right here. So we got a few volcanoes there. I guess not Olympus Mons. Olympus Mons is a little bit further around. That's a different volcano. Let's see, that one is Albortholis. Oh, that's one I don't know. And so we were seeing this part here, Hellas Planitia, sort of not quite into this area over here, which is Arabia Terra. This is where The Martian, the movie The Martian, is set. So Matt Damon is stuck somewhere out in these craters, and he's got to make the trek to the Pathfinder rover, which is somewhere over here. I think the spacecraft, yeah. Is that where Pathfinder? Yeah, there's Pathfinder right there. So Matt Damon was stuck over here somewhere. Anyway, the pictures that I took last night of Mars looked like this. So pretty similar. I mean, exact same telescope and camera. And a very similar, actually, part of Mars. So again, Hellas Planitia is that light area right there. And then Arabia Terra is up here. And that kind of checkmark dark area that we saw last night is just, let's go to the visible here, kind of this checkmarked dark area right here. See this kind of V-shaped dark area, like so. I took an image, and then about an hour later, I took another image. So here's the first image. Do I still have the second image open? I guess I don't have it open here. Oh well. But what I think is actually great about this is that it shows the polar ice cap. Now, it's spring on Mars. I think it's spring. And so the poles of Mars are kind of tilted, not really tilted towards or away from the sun. We see Mars fully illuminated because the sun is behind us, right? So we're passing between the sun and Mars in our orbit. So the sun is back there. We're seeing Mars fully illuminated, just like the full moon. And you can see that polar ice cap. The ice caps will get bigger and smaller depending on the season. And it's not very big right now. It's not very shiny or reflective right now. All right, well, that was last night. Let's take one last view live view of Mars. And then I need to actually sign off soon to go do some work. If anyone has any questions, feel free to type them in the chat. I'll be on for another 5 minutes or so. And I can answer your questions. Let's go back to the live view. Okay, so there's the all-sky camera. All right, and then here's the video camera. Hey, it's getting better. It's getting better. I'm seeing more detail. I don't think I can see the ice cap. Now, Mars has a rotation period that's just a little bit longer than the Earth. It's like 30-something minutes. I forget exactly the exact number, but it's 24 hours and 30-something minutes. And so that means if you look at Mars at the same Earth time, it's going to be rotated about to the same the same place. You're going to see about the same surface features. So here I'm looking at Mars at about 9 p.m. Last night I was looking at Mars at about 11 p.m. to 12 a.m. And so I'm going to see more or less the same side of Mars. I'd have to wait a few days for us to get the rotation a little bit out of sync in order to really see the other side of Mars with Valles Marineris and the Olympus Mons and so forth. But still, yeah, pretty cool view. And Mars is going to look this good all month. Don't think you're missing out if you're not seeing Mars tonight, because it happened to be closest to the Earth tonight. It's going to look exactly the same in 2 weeks or 3 weeks. Maybe in 4 or 5 weeks you'll notice, oh yeah, it's getting a little bit smaller and dimmer, but you won't notice it looking any different over the next few weeks. All right. Well, like I said, I'm going to have to sign off, getting close to 9 o'clock. So checking to see if there are any more questions. Oh, Fred, you're going to go out and look at Mars, definitely. What's my email address? Yeah, I'm happy to give out my email address if anyone has questions, wants to email me questions or comments. So I'm at Yale. My email address is michael.faison, so Faison at yale.edu. That's my email address. Happy to get questions from people viewing the live stream. Trying to do these every week, although things are really busy. Things are actually, even though I'm the only person at the observatory, things have been really busy this semester up here. So trying to do them as often as I can, do the live streams as often as I can. I didn't even have time tonight to talk about the Nobel Prize in Physics, which is a big announcement today. It's always, astronomers are always excited when there's a Nobel Prize for an astrophysics topic. And two astronomers and a physicist got the prize for studying black holes, and in particular studying the supermassive black hole at the center of the Milky Way. So if any of you are frequent visitors to Leitner Observatory, and if you've seen the black holes show that we often show in the Planetarium, the ones narrated by Liam Neeson, has really nice visuals in it. It's a little bit over the top for my taste, but you get to fly into a black hole, and it's a good show. But they profile Andrea Ghez from UCLA, an astronomer at UCLA, and she is a co-winner of the Nobel Prize in Physics this year for making the discovery of the supermassive black hole at the center of the Milky Way. And I'm astonished to hear that she's only the fourth woman to receive the Nobel Prize in Physics. I was thinking about who are the others, Marie Curie, and then I'm not as familiar as I should be with the others, but astronomy is a small field. We all sort of know each other as acquaintances or friends of friends. And I know that she's worked on this project for decades and done amazing work in it. So it's really wonderful to see her hard work and perseverance and amazing science rewarded with this prize. That's well deserved. So maybe I'll get out the Black Holes show, the Planetarium show, and show that in the live stream next Tuesday if it's cloudy. And we can talk a little bit more about the black hole, the Nobel Prize for the black hole discovery. Richard, can you show the black hole video? I think I can. I have to see if I can get the right format for the screen, but I think I probably can. So I'll work on that before next Tuesday. Put that on the docket. All right, well, I'm going to have to sign off. Thanks to everyone again for tuning in. I'll post some pictures of Jupiter and Saturn and Mars in the description for the video. So if you come back and look at it in a couple of days, you should see those. And like I said, I'm happy to get emails if you have any questions. Michael.faison, Faison at yale.edu. We have a website where we are keeping people up to date on events that we might have, live streams, things like that. So that's Leitner Observatory. Leitner observatory.yale.edu. That's our website. All right. Thanks everyone for watching. See you next time. All right. Bye, everyone.